Alright, locomotive control, electric motor division, GPS static control, GPS static control, March 1964, our flag and fallen flags, electric motor division, General Motors Corporation, LaGrange, Illinois, USA. The GP locomotive utilizes the 16 transition positions covered the speed range from 18 to 71 miles per hour. A 62 to 15 gear ratio. The position follows the percentage given in the nominal series package fully motor field shunt, 20% motor field shunt, 35% motor field shunt, 44% motor field shunt, 51% motor field shunt, 57 motor field shunt, series 7 parallel, 61 motor field shunt, series 8 65 motor field shunt. Alright, you have extras, series 9 series panel, 68 motor field shunt, and 65 when in effect. 10 asterisk, 70% motor field shunt, 65 when in effect. Figure 11 parallels, full motor field strength, 12 parallels, 20% motor field strength, 13 parallel, 35 motor field shunt, 14 parallel, 44 motor field shunt, 15, 51% motor field shunt, parallel 16, 57 motor field shunt. Alright, the 16 transition position step is automatically controlled with the 2E1 type, the transition E, the FTR with the BTR with the forward transition relay, and the picking up the initiates the full transition during the train acceleration of the back transition relay. Dropout initiates the back transition during the train deceleration. A third E1 type relay of the positive power transition relay. It remains percentage of the motor field shunt with the tolerable and more motor fields are hot. Considering the circuit simplification accomplished through the motor pool, multiple pole 10 mode position motor driven as cam switch of the program switch, the device is derived from the name of the function of the programming the locomotive through 16 transition positions, a 10 series parallel and 6 parallel, 10 series parallel and 6 parallel. The 10 position series of parallel are obtained with the first complete 360-degree revolution of the program switch. The 6 position parallel are obtained with the program switching of the rotating past the position of 10 to the position 6 while the motor are connected in parallel circuit and in parallel. 4 motor shielding contactors FS1, FS2, FS3, FS4 are individually combination of obtaining the step of the motor of the field shunt. The combinations are as follows: the field shunt motor of the 20%, field shunt number 2, 35%, field shunt number 1 and 2, 44%, field shunt number 3, 51%, field shunt number 4, 57%, field shunt number 1 through 4, 61 motor field shunt number 2 through field shunt number 4, 6 field motor field shunt number field shunt number 1, field shunt number 2, field shunt number 4, 68 motor field shunt, 65 when in effect, field shunt 3 and 4, 70 motor field shunt, 65 when in effect. The percentage of shunt given in the calculated electrical resistance traction motor field when during the nominal operation for the region, the last two steps that should exceed the 65 allowed with the transition control system when the traction motor fields are cold. All percentage would increase, but the percentage of the shunt accomplished last two steps would fall below 65%. Alright, these are a lot harder. We'll try our best. So transition control circuit with the transition program switch with the position 1 serial rails per 13 through 14 are picked up with the motors connected with the serial rails per full speed since the locomotive is traveling the full very slow speed after the following transition relay. The forward transition relay, backward transition relay has mixed up with the parallel transition. The power transition relay is not connected with the transition circuit at this time. The transition program switch 2 is in the CD auxiliary contact with the parallel power contactor are open with the switch in position 1. The series parallel prevents the energy reaching the program switch and the armature driving the switch backward past the position 1. The following text should be assumed that the locomotive operating is at full power. This is the throttle and run position 8. Alright, this is starting a train. You have your main generator. Let's try to increase that. You have your main generator. All right, it goes through the field transition relay, and there's the backward transition relay. It goes through different circuits of the SF. All right. You see the different field shunts 1 through 4 and 1 through 4, and then it goes into two little motors. With a series 2 with a relay, and then power relay 2 and 4. And then you have field shunt 52135, 52134, 51234, and with this you get your different parallel circuits and acceleration and motor caught off with the percentages. They're all traveling on this one, but it's different opening gates between the field shunts. For instance, field shunt number 1 and field shunt would be like 20%, and then field shunt number 2 would be 20%, and then so on, like we read before. This also shows the reversers. I guess that's what stands for R. R stands for, and your different polar contacts over here with the currents, and really hard to draw, like to read, to show. It's a little bit hard to show. Figure 2, the locomotive is accelerated with the train speed resulting in the system voltage of the 925 with approximately 1800 main generator amperes. As the position of the back transition relay picks up the front transition relay, stop the drop of the field shunt auxiliary relay at the field shunt auxiliary contacts A1 and 2 if that has been dropped. The time lower the pickup of the volt rally with the back transition relay, but the incident of the time since the back transition relay calibrated pick up with the front transition relay, regardless of field shunt auxiliary A1 and 2 contacts. The resistor and circuit through JK and LM coils are calibrated by the back transition relay, which will pick up the low main generator voltage. Drop of the front transition relay has dropped out. The back transition relay picking up the down. Do not make the break in any circuits for the assembly condition where the back transition relay drop out and can cause the back to switch to step backward if it has stopped. Once again, you have your front back transition relay on the main generator positive and negative side going through switch. These two switches relays, both 3 different motors and 2 different series. Which has different poles and gates to turn on the different relays. R is for relays, and then once again, you have your field shunt relay gates, and then field shunt control transistor, parallel 1, 2, and 1 on 2 going to, and 3 and 4. And then relays going to the TR switches, which also go through a whole bunch of fuses, and current relays. I don't know how to read this one. The amateur field shunt relay, front conductor, iron core. I don't know how to read that one. It's kind of hard to read the book and to just do this. Like, figure 2, though, the locomotive has reached a speed approximately 19 miles an hour. The front transition relay picks up approximately 1,000 volts at 1,750 amperes. The main generator, the front transition relay contact C to E closes allows the current to flow from the positive side auxiliary generator through the normal closed contacts. A 1 and 2 transition relay TR through the transition program of the switch motor armature to cause the program to switch to rotate the position toward the position. Alright, once again, you have your field shunt relays controlling the percentage drop in the series and parallel current circuits at different miles per hour. For instance, 20, and then FR3 and 4 would be the highest amount of percentage you can run through the main generator or the front transition and back transition relay to the front shield relays with the alright. The program is now moving the position 1 towards the position 2 that requires then less than a second to reach for the center of position. Figure 2.4 shows the condition is approximately 9 degrees at the rotation point with the same with the cam development. The transpositions TPS contact closed series parallel program switching armature now can receive the energy of TPS 1 CD contacts PPR 8 and 6 contacts. Alright, this shows the field shunt relay 1, 2, and 3, and 4, and field shunt relay number A. The different that goes to the TPS contacts 1, 2, 3, 4, 6. That's TPS contacts closed 1. In figure 2.5, the program switch has rotated approximately 20 degrees, entered with the 2 position at the point of the TPS3 and TPS3, and TPS2, TPS3, TPS7 contact closed AP contacts, TPS9, TBS contact closing is not effective at the time, but it sets up the circuit to drive the program. Once back to the position issue 1 should the locomotive speed decrease. TBS 13 contact closing of the picking up the motor field shunt contact or field shunt with the CD contacts field shunt 1 closes to pick up the field shunt accelerator. The TPS, the terminal package power switch contacts the or energize the interrupted relay, inter IR, the contacts the interrupted relay, AB and CD short with the front transition relay, JK and L and M coils. For the purpose of the explanation and clarity, depicted with the figure 2.5 front transition relay has not yet dropped out. Tactical terminal parallel circuit. Contact closed with the closing of the interrupted relay. Contacts E5 with the auxiliary generator control the energized the back transition relay. NP coil with the 300 milliamperes control the current with its hold with the BT back transition relay. Picked up the main generator voltage drop. The result with the major motor field shunt with the closing of the terminal power switch. AB contacts preventing accidental fuses and dropout change of the motor fields. All right, guess like down here it shows the different field shunt power switches. It's like as you can see a gate here. These are gated like these relay old traditional, and then these relays with the front transition, back transition, your transition relays, and back transition once again through field shunt and tactical terminal field shunt, and also with your field shunt currents. Two completely different drawings. Basically the same thing, though. It's done. This says alternator, and this one says auxiliary generator. This one says main generator. These would be your excitation transition motors. Front transistor has dropped out over the front transition CD contacts interrupt the flow of the track interrupter relay. Coil. The interrupter relay means that they picked up the energy stored with the capacitor. CA4, the capacitor will keep the interrupter relay picked up with approximately 1 second. The program will switch. Motor armature receives energy with the terminal power switch 1. CD contacts terminal power relay 8.6. The transition program switch continues to rotate forward in center position. Those are not terminal powers that transition. The transition program switches. So these field shunt have the different relays, 1 through 4. The main generator, the shunt series field, backward transition relay, frontward transition relay, transition relay, switches, fuses, gates. Also, what you want to note about this is they have a capacitor, CA26, whereas this one goes on the alternator side of the auxiliary generator. Setting up a front transition relay drops out. In Figure 2.7, the program switches have reached the point within approximately 9 degrees with the center of the position 2 that shows the point of the transition program switch, which has reached the point with approximately 9 degrees of the center position 2. The transition program switch 1 contacts the open and interrupts the flow of the program. The switch the motor armature sends the motor to the permanent magnetic field. A current generated the rotation armature is in field. The current is dissipated with the resistor, but below the action of the dynamic brake for the stop of the armature abruptly, since the current is no longer flowed with the motor through the transition program switch. Coil, the transition program's reluctor relay transition program relay contacts 8 and 6 open. Interrupter relay drops whenever the charge of the capacitor CA26 is exhausted. Remove the short of the round with the front transition relay JKLM key coil through the flow of the current. The NP coil of the back transition relay delay drops out, interrupting relay alternator generator voltage stabilized. The conditions are not set with the program static, but the locomotive and speed increases, step down and decreases. Field shunt relay has picked up the transition program switch 3 allows to pick up the position 2. Field shunt auxiliary is held with the field shunt 1 and CD auxiliary contacts the transition program switch 9. AB contacts transition program switch 2 being closed with the possible the back transition drive out. The program switch to position 1. The back transition drop out due to the loss of the locomotive speed. Alright, so when the main transistor, this is basically telling you that when the field shunt drops the relay, it will drop, the interrupter receives it, and the capacitation of the wire changes the switch. So you're switching on from the TPRs to the switches of the field relay resistors. Different drops in voltage turns on different field shunt relays. As the locomotive continues to accelerate, the program will step in the front transition, pick up the sequence of events for the step through the position 9, like with the going through position 1 and 2. However, the compensation circuit is involved with the step 5. The circuit is explained with the article position 6. Alright, the position various contacts shown with the after the group is shown with the stop in the position 3. The interrupting relay has dropped out. The traction motor field is now shunted at approximately 35% sold. System voltage is now 9,500 volts in position 3, 3,500 volts. These have changed. Terminal position, this is the armature they were talking about, which drops the circuit and the relay, drops the voltage, the front transition, back transition relays, the field shunt wires on the next loop. It's very hard to show you all the parallel circuits and the different runs they go, so I'm just going to brief you on them. As the locomotive continues to accelerate, the program switch has moved to position 4, shown in figure 2.9. The field shunt relay mains picked up the field shunt 1, picked up again and put in 2 resistors parallel across the motor field. This result in 44 shunt. So alright, when you have field shunt 1 and 2, you have 44% shunt. The system voltage drop at the 950 volt. The 44% front transition does not pick up the back transition relay drop. So we're in figures 1 and 2. All these field shunt 1 and 2s have been turned on, and it's 44% shunt speed in position 4. Figure 210, the program switches to the top of the position 5, field shunt 1 and field shunt 2, the dropout, and the field shunt 3 picked up. As the result, approximately 51% motor field shunt. As a result, the system voltage is dropped to 9,500 volts. The pickup of 50 field shunt 3 with the contacts E and F that did not function now function at this time. E and F, E and F, E and F, E and F, E and F. Alright, so now we've dropped 1 and 2, and now we're just running on 3 on the different motor circuit series of the parallel field shunts. Alright, in figure 211, the program switch is stopped at the position 6. The field shunt 3 has dropped, and field shunt 4 has picked up. The result of approximately 57% motor field shunt. The result of the drop of the traction motor field shunt strength dropped, and system voltage approximately 9,500 volts. Of AB contact the field shunt 4 with the down contact with the parallel transition power transition relay across the power main generator through the JK contact. The field shunt 4 connected with the field current transducer, front current transducer, and similar transformer T5 across the alternator, picking up the field shunt 4 with the contact E and F, and the Q and R has no function at this time. Alright, Q and R. I see the R, but I don't see the Q. Where's the... Alright, these, I can't see the contacts. I don't think I see them, though. It's just... I understand, however, the action of the power transition directly, but the transition full powered motor connection brings it about the step motor field shunt, the power transition relay, operating construction current with the field current with the transducer, front current transducer of the percentage of the motor shunting with the limits of the traction motor field shunts to hot. The holding action interrupts the person of the shunt around the motor field. The transition system, seeing the need for the more shunt, causes the program to step up and initiate the transition from the series power to the parallel motor connections. All right, in position 6, the shunt is at 57. In figure 12, the program switches stopped in position 7. The field shunt 4 picked up and field shunt 1 picked up again, putting the 2 resistors in parallel across the motor field. With the result of the 61% shunting, assuming the traction motor fields are relatively cool, system voltage is now dropped to 95 volt, 150 volts, approximately 1,830 main generator amperes. This runs running off the field shunt number 1 and 4 on the on your traction motors 1, 2, 3, and 4 on series 2, 4, and series 13. All right, something easier to read. In Figure 212, they assume the operating conditions of the traction motor field that are hot and field with resistance increase with the nominal of the 96 thousandths of an ohm over the cool motor with a nominal of 12 thousandths of an ohm over the hot motor. The resistance of the field shunt 4 and 1 contact the pair rails across the motor field. The shunt resistor becomes relatively cool compared with the motor field's draw of the greater percentage of the current. The effective percentage of the shunt is greater than allowable to damage. Damage of the traction motor armatures could occur with the ring occur as a result of the ring fire. To prevent excessive percentage of the motor shield plant with the power power transducer will pick up the interpreter control the current of the field shunt 1 that accomplishes the action of the field current transistor transducer first front contract field current transducer FCT. During normal operations here, parallel, the field shunt 4 picked up the motor field current flowing the cables passing through the frame of the field current transistor, and to decrease the impedance of the field current transistor, field current transducer coils, and decrease the impedance current flow of the primary transformer to T5, resulting in a current flow for the secondary T5 with the passing of the P and N coil, the power transducer relay following the power end of the close. The power transducer picked up the PTR. The EF contacts remain the close. All right, your main generator going to a number 2 motor field your field current transistor, breaking the 0-1200 ohm the ohms for the hot motors that field shunt 1, 2, and 3 and 4 with OD64, which is I don't know, the different rectifier with the power transistor, parallel 4. These are used as fuses, but they're not like. And the other ones that show the searles, so let's just call them gate relays, power transistor relays, and R, which. All right, the bottom one shows the alternator going field shunt 4, the front contactor transducer, transformer 5, 4 rectifiers holding on to the A through the negative and positive coil of the two-way cycle, positive transition, power transistor, reader NMP. Also, the accelerator shows the TP gates of 3, TPS gates at 3, 4, and 5. And field shunts for 3, field shunt 1, field shunt 4, 2, field shunt 5, field shunt 3, field shunt 4, 6. However, if the motor fields are hot, increase the resistance causes a less current flow than the cables passing through the front of the front contact transducer flux density core of the front contractor field current transistor. Flux density of the field current transistor to decrease the impedancy of the field current the field current transducer coil increase the current flow for the transformer 5. Consequently, the P and N coil, the power transducer relay, sufficient to hold the power transistor drop out. The JKLM coils pick up the power transistor relay. And these are examples of the power transistor relay. E5 of the contacts pick up the interpret the flow of the current with the coil of the field shunt 1, even though the program switch position coil of the field shunt 1. The CD contacts the power transistor relay closes the recalibrate the pickup of the PTR on the positive transistor relay and the positive transistor preventing cycle. Power transistor relay action compensates with the hot motor field that prevents the exceeding of the motor field shunt. Since the motor field loses all shunt, but the field shunt 4 of the power transistor picks up the system voltage remains in high, calling for more shunt. The program switches will continue with the stop of the transistor parallel current occurs. Power transistor relay pickup of the type that's taking place during the series parallel motor connection at the field shunt pickup during the 6 program switch position. Actually, use the number operating condition. The power transistor relay will pick up the program switch with the position 9 if only the motor fields are cold and that in the 9th and 10th shunting position of the program or switch is needed. Alright, in figure 24, the program shows the switch has stopped and field shunt 4 remains picked up. The field shunt 1 is dropped out, and field shunt 2 is picked up, holding in the resistor differential value parallel. The result is 65% shunt. Since the system voltage dropped at 955 volts due to the 65% shunt, the front transistor relay and the back transistor relay drop out. Figure 215, the program switches the position with the back position with the field shunt with the 4 and 2 with the pickup. The first field shunt 1 and picked up again with the putting 3 resistors in parallel. This will result in 65%, 55% or less. The result of the system voltage is dropped to 955 volts. Notice the percentage of the shunt position 9 is shown in 65 is the position of the percentage of the given with the position 8. The reason for the apparent discrepancy, the fact that shunting percentages are calculated with the traction motor warm is during the normal operation of the power transistor relay circuit previously discussed will not allow more than 65% shunt. Therefore, a program switch normally switches through the position 9 and 10. Full parallel transition. This is only the motor field's exceptional cool with the step 9 and 10 with the effect that at the time of the shunting of the ignite not exceed 65%. Figure 216, the front transistor relay has picked up the program with the switch with approximately 9 degrees position. The transistor power switch and the transistor power relay contacts 8 and 6 as the instant program switch has rotated enough to pick up the contacts nor drop the already picked up. Therefore, the transition power switch is still closed. The interrupter pickup relay picks up for the purpose of explanation. The front transistor relay now shows the dropout. Alright, figure 27, the program switches the rotated 20 degrees to position 9. The transistor power switch 3 and 4 open, dropping the field shunt 1 and 2. The transistor power switch open, the field front transducer relay drops out, and the interrupter relay still held, picked up the charge and capacity CA26. Alright, that in figure 217 was stepping up at the position 9 front transistor relay drop. In figure 218, the program switches the stop of the position at 10 with the field shunt 1 and 2 with the dropped out of the field shunt 3 with the picked up, the putting the 2 resistors parallel across the motor field with the resulting in 65% shunt. Transistor power switch 8 contacts closed since closed after the front transistor relay drop with the current path. The transition relay was completed with the path is however set up with the energized transistor with the next jam of the front transistor relay pickups. The foregoing sequence of steps 6 through 9 will place the power transistor relay pickup with some after the power first field shunt 4 picked up at the position 6. This program switch will step off the position 10 with the field shunt and contact actors exemption. Field shunt will not be energized. Noticing the CD contacts power transition picked up against for the cycle of the power transition E5 with the contact opening caused the field shunt 1, 2, and 3 with the dropout. Figure 218 stopped in position 10 with the transition relay setup. 8. Alright, on this outside one, you see the auxiliary generator goes into field shunt 1, 2, 3, and 4, and field shunt auxiliary. And then the auxiliary goes from the to field shunt 3, 4, and 5, 4, 3, and 2, and 1 to terminal power switch, or terminal power switch 3, 4, and 5, and 6 that are lined through the field shunt power. And then power transition relays. Back transition relay, and in the middle you have a transposition armature and training power switch relay, training power shift relay. You have a couple reluctors and front transition power transition relay down here. Capacitator. Alternator field shunt on front contact transformer relay, field shunt 3, 4, 3, and 5, power weld 2 and 3 and 4, back transition field shunt accelerator, Figure 219 has picked up the control of the flow of the control of the terminal transformer power switch 8. The program switch of the armature allows the come through the closed contacts JK and I interrupt the relay, and through the closed contacts the relay 1 and 2 the field shunt auxiliary energizes the transistor relay. The AB contact with the transition power switch 9 opens the program switch and rotates. Alright, transformer pick up the flow of the current of the field contactors interrupted the all shunt remove the motor of the field. They simultaneously pick up the C1 and C2 contact with the transition relay shown in figure 220. Cause some of the field contactors short shield front the battery field contactor BFA to drop out. The BFA dropping out to remove the all excitation of the main generator. The battery field shield front dropping out, and the 250 ohm resistance the shield front circuit. The system voltage decay at the rate which requires the two and a half seconds to drop the 1,000 volts, approximately 500 volts. The reduction power is controlled at this rate to make the transition smooth and possible with without loss of speed. Alright, notice the transition power switch of the 7 and in the open position 10. There are no current flows. The interrupting relay coil, the front transition relay, JK and LM are shorted. However, the pickup of the TR contact NL and N2, drop of the field shunt 3 EF and field shunt 4 MP contacts allow the 94 milliamperes control current to flow through P and N. Coil the front transition relay cable. The front transition relay drop out approximately 500 volts low generator current. Front transition relay then drops out about 2.5 seconds after the generator volts drops at 500. In the meantime, the front transition relay contacts A and B remains to keep the front field shunt auxiliary energized. The sole purpose of the front transition relay A and B contacts. Alright, so it shows the shield front and the battery field accelerator or contactor. Negative from the auxiliary generator to the contacts 1 and 2 and transition relay D1 and D2 with the power relay 4 with the HG shield front relay within the battery field contactor BF and shield front and back on the shield front line. Alright, it shows the next step in the accomplishing series parallel motor transition system voltage decay with the 50 volt, the front transition relay drop, the front transition relay AB contacts open, the front transition auxiliary, front transition auxiliary D1 and 2 contacts opening the drop series 13, series 13 AB contacts contact the energized P1 and P3 with the close, F1 and F2 contacts TR and transition relay of the transition relay pick up the contact P1 contacts of the drop of the C24 and C24 A and B contacts close the energized the P24. Meantime, the program switches the rotated with the position of the 10 position of the full parallel. Unlike with the GP30 transition control system, will utilize the 10 program switches positions do not allow the program switch to rotate the 10 positions. Alright, this shows all the different switches for your power transition relays. You have 1, 2, 3, 4, 5, Series 13, and Series 24. Through power relay 1 and 3, you have the F1 and F2 transition relay, the brake control power 2, and field shunt auxiliary through F1 contact F1 and F2 that later connect to the to an A and B Series 13 circuit. If you want to ride the 13, and just before we go over the Series 13 part of the Series 13 circuit, the positive is on the. We'll go through the P2 parallel circuit P2 and P4 parallel gate switch 1 and 2 it contacts E and F. Go to A and B Series 24, and then the so power circuits 1, 2, 3, and 4 are riding on the 1 and 3 go to A, B, and they line up on the A and B of Series 24 and Series 13 contact. And then on the current control of the current, the AB power parallel 1 rides the outside to AB parallel 2, which goes to Series 24 negative, and Series 13 rides the field auxiliary to D1 and D2. The Series 13 and 24 come in their relay contact. From field shunt relay in between around parallel lines, you have the transition relay also running on the Series 13 for outside negative ring. Alright, in figure 22, the program switches have rotated to position 10 with the stop at position 1. The motors are now connected with the parallel full field. Notice that the C&D contact's parallel power contactor P1 has shorted out. Transition power switch 2, the contact for the open. The position 1, this allows the program switch to set back at the position 10 should locomotive speed drop. The CD contact power contacts P2 and P4 open with remove the current control of the front transistor relay with the power P and N coil with the front transistor relay JKL and LM coils free to pick up the front transistor relay should locomotive speed increase. The transition relay R1 and R2 contacts have closed to recalibrate the front transition relay. Pick up the parallel motor connection. The program switch can now be step up the position 1 up at the position 5 of the parallel in much the same way that they stepped in a series parallel circuit. Alright, notice the A and B contacts of P4 interrupt the circuit with the JK and L and M in power transition relay during the power parallel transitions. Alright, in figure 22, you see a position parallel 1 full field. Figure 223 shows the program in switch 5 parallel 15 position comparable to position 5 series. The field shunt 3 picked up with all the field shunt contactors dropped out. However, the A1 and A2 contacts of the transition relay are open, while the front transition relay again picks up the program switch to the motor and gets energy from the EF contacts of power 3, P3 and F field shunt 4. In figure 24, the field shunt transition relay picked up the program switch rotated 20 degrees power to position 6. Interrupting relay picked up the short of the front transition relay JK and LM. For the purpose of explanation, front transition relay is now shut. Won't drop it. The program switch is not rotated far enough to drop the terminal transition parallel switch 5 to transition power pickup or to pick up transition parallel switch 6. Alright, figure 24 shows the stepping up the position 6 parallel. Alright, in figure 24, the program is stopped at the position 6 with the field shunt 3 with the drop of the field shunt 4 picked up with the E and F contacts field shunt 4 picking up the eliminating the possibility of feedback program with the armature should the front transistor pick up again. Therefore, the final step of the parallel motor field shunt, the A and B contact the field shunt pick up since the A and B contacts the parallel 4. Power transition relay JK and LM are not energized. The LM contacts of the field shunt 4 merely are acting in full to hold the power transition dropout. The JK contacts of the F field shunt 4 the front transition relay pick up the recalibrate series parallel at a higher pickup of the value speed more than approximately 75 miles an hour or 62 to 15 gear ratio between the front transition relay. Again, pick up the front transition pickup that indicates the true train overspeed the 8 wheels simultaneously simultaneous wheel slip. The wheel slip relay is energized. Alright, figure 25 shows the top position in parallel 6. Alright, should the locomotive decelerate due to the increase of the grade of the program, which will stop in a manner similar to stepping up the figure 26 locomotive decelerated point with the system voltage drop with between 800 volts drop up the back transition relay. The back transition relay dropped out the front transition relay, not picked up in position 6 position with the program armature energized the direction starting with the rotating toward the positions 5, the simultaneously current with the 3 to 1 transition power relay, causing the contacts 8 and 2 to close. The back transition relay E and F contacts closed the energize the overriding solenoid engineering govern the drive load regulator toward the minimum field position, thereby maintaining stable generator voltage. Stepping down off the back transition relay, back transition relay on the back side, JK and L and M. Figure 27 of the program switches approximately 9 degrees toward the position 5 of the parallel. The transition power switch 1 contact has closed. The interrupting relay has picked up the up and shortened the front transition relay coils, energizing the back transition relay at NP, which continues rotated toward position parallel 5. Figure 28, the back transition relay has picked up due to the 300 milliamperes current control current. The NP coil of the back transition relay opened up and interpreted with the circuit of the interrupting relay, but is held with the pickup of the energy stored in the capacitor CA26. The program in the switch armature now gets energy with the transition power switch 1 and transition power relay 8 through 2. 8 to 2 continues to rotate toward position 5. Alright, in figure 29, the program switch is approximately 25 degrees from the position 5. The transition power switch is open. The transition power switch 5, as a result, the field shunt 4 has dropped out, and the field shunt 3 is picked up, but the motor fields are now shunted at 51. The program switch continues to rotate toward the center of the position 5. Alright, in figure 230, the program switches to reach out with a point of 9 degrees to position 5. The transition power switch is open, stopping the program with switches abruptly. Transition power relay contacts 8 and 2 have opened. Figure 231, 1 second elapsed since the transition power switch opened. The program switch with the top near the center of the position 5. The interrupting relay dropped out with the back transition relay. Held with the system voltage approximately 850 volts. Should the locomotive continue to decelerate due to the grade of the program switch, will step down in position corresponding to the balance of speed of the locomotive on the hill. Since the sequence of the events identically occurring with the going of the position 6 and position 5 are not shown here. Should the grading lessen the program, which should read the step back of the position 6 of the dictate with the front picking up the front transition relay, noting that overriding the solenoid, the engine and going energized with the back transition relay dropped, reducing the main generator excitation provides that such transition. However, during the transition full parallel connection, overriding solenoid energizes the closed C and D contact shunt field conductors shunt field. In addition, with the program switch normal step, the down position 10 and 9, but lesser percentage of the shunt back transition relay E and F should be closed for the keeping the ORS energized with the shield contactor open. As a result, the load regulator will overdrive in the turn toward minimum field with the resulting lost power to prevent this time delay relay. The time TDB is energized with the transition, but from the parallel to series parallel occurs in the delay. Alright, section 3, dynamic brake control.